This is Professor Pelton. This is Algebra 2, Chapter 5, Section 2, Properties of Rational Exponents and Radicals. Rational exponents and radicals. So here I've stated the properties you've been using for years, pre-algebra through geometry. The difference being is now the exponents themselves can not only be positive and negative integers, they can also be fractions, as we'll see. So nothing changes, although I did elongate this to the negative exponent rule, because if it's negative, it goes to the numerator, and if they're both negative, they essentially just swap. So add those to the list. But everything else is pretty straightforward. So if you don't remember some of your exponent rules or your power properties, you should review. Let's do some problems. Okay, so though this is the product. So this is the product property of exponents, or product rule. Since they have the same base, you can combine them with addition. So it's 5 and 2/3 plus 4/3. So 5 and 6/3. You should always simplify fractions when possible. So that's 5 squared, 425. All right, next one. It's also the same bases of 2, so you can combine them. So it's 2 and 3/4 plus 1/2, which is really 2/4. So that's 2 and 5/4. 5/4 cannot be simplified. So there's two possible answers here, though, because we can write it in the radical notation. So it's the 4th root of 2 to the 5th power. So either one of those is a sufficient answer, depending on whether they want a radical or an exponent answer. All right, power to power rule is multiply. So that's 4 to the 6/3, or simplified 4 to the 2nd, which is 16. Next one, power of product, which is basically power to the power rule multiple times. That's 5 to the 2/2 and 16 to the 2/4, because that 2 has to go to everything inside using the power to power rule, which is multiply. So these are not the same bases. These is 5 and 16. The other ones were both 2 and both 5. They're not the same bases. The product rule does not apply. You cannot add those exponents. However, we can simplify here and get 5 to the 1 and 16 to the 1/2. Again, they still don't have the same bases. You cannot combine them with the product rule. The product and quotient will require them to have the same bases. They do not. So this is 5 times the square root of 16. So either of these is a sufficient answer. All right, let's scroll down, try the next three, or four rather. Okay, so again, the 2 is going to go inside using the power of product. So 2/2 and 2/3. So that's 6 to the 1 and 4 to the 2/3. They don't have the same base. They cannot be combined. Or 6 to the 3rd root of 4 to the 2nd power. Either one is a sufficient answer, whether they want it in power or exponent form. Next one is a quotient rule. We must subtract. So that's 5/2 minus 1/2. So that's 8 to the 4/2, which is 8 squared, which is 64. Always look to simplify fractions when the final answer. Well, the next one is also a quotient rule. There's nothing in the numerator, but there really is. It's a 1. So that's 5 to the 3/3 over 5 to the 1/3, because 3/3 is 1. So that's 5 to the 3/3 minus 1/3, or 5 to the 2/3. All right, last one. Power of a quotient, which means it goes to both. Whenever there's a parentheses, basically share with everybody. Don't be stingy. So 6 to the 2/3. Okay, so these do not have the same basis. The quotient rule does not apply. Same as the product rule. You need equivalent bases. However, if you think about this, this is 42 over 6, all of the 2/3 if you pre-distribute or undistribute it. So 42 over 6 is 7. So whenever you have the same exponent, you can also do the operation, but that's only if it's the same exponent. So, or the 3rd root of 7 to the 2nd power is an equivalent answer. So either one of those is fine. Pause the video, try the next page. Okay, next page. Product property. So we have addition, so it's 3 to the 5/5, or 3 to the 1, which is just 3. Next one is product also, same basis, we can add them, so it's 1/4 and 2/4. So that's 7 to the 3/4, or the 4th root is 7 to the 3rd. Either one is an equivalent answer. All right, let's move it up a little bit. Okay, power to a power means multiply, so it's 10 to the 4/2, which is 10 squared, which is just 100. Next one, the 1/5 need to distribute to both. It's power of a product. Whenever you see parentheses, distribute to everybody. So that's power to a power, which is multiply, so that's negative 5/5 and 3 to negative 5/5. All right, 5 times 1/5. So essentially we have 4 to the negative 1 and 3 to the negative 1 using the negative exponent rule. We have 1/4 times 1/3, thus 1/12. So as you can see, if there are whole number exponent solutions, it's just first power here, you get one possible answer. If there is a fractional exponent left over, you have two ways to possibly represent the answer. Try the next ones. Okay, power of a product. You can't combine the insides first because they have different bases of 5 and 7. So it's 5 to the 3/3 and 7 to the 3/4, which is 5 to the 1 and 7 to the 3/4. Again, different bases, not possible to simplify. So it's 5/4 roots of 7 to the 3rd. So either one of those is a sufficient answer. Next one is a quotient rule. We need to subtract. So that's 7 to the 2/3 minus 5/3, or 7 to the negative 3/3, which is 7 to the negative 1. Use the negative exponent property, 1 over 7. Okay, let's move down to the last two. All right, for G, there doesn't seem to be an exponent, thus there must be the 1 placeholder. So that's 3 to the 4/4 minus 1/4, because quotient rule is subtract. So that's 3 to the 3/4, or the 4th root of 3 to the 3rd power. Either is sufficient. All right, next one looks like a quotient rule inside. They do not share the same base, thus they cannot be combined. We can distribute the 3 using the power of a quotient, because when there's parentheses, everything must get it. So that's 20 to the 2/3, not 2/3, 3/2, I'm sorry. To the 3/2 over 5 to the 3/2. But again, if they have the same exponent, you really have this. So you really have 5 to the 3/2, or you can rewrite it as the square root of 5 to the 3rd power. Either way, it's a decimal answer, but we want those two possibilities. Oh no, that's 4. I'm sorry, not 4, 5, it's 4. We messed up there, I'm sorry. So that's 4. That's 4 square rooted. Square root of 4 is 2. 2 to the 3rd is 8. That is our final answer.